Welcome to this video on building AI native testing systems, focusing on the context problem in AI coding. When AI generates code, it often lacks project-wide understanding, resulting in incomplete or incorrect code. So what exactly is context? Context is all information available to the large language model, or LLM, when it generates code. This includes the existing code, documentation, dependencies, and the initial prompt. The core problem is that incomplete context leads to incorrect output. When an LLM receives fragmented input, it attempts to bridge the gaps by approximating logic, which can result in bugs, flaws, or vulnerabilities. Context is multifaceted, encompassing many layers, including the codebase, dependencies, architecture, domain knowledge, tests, recent changes, intent, constraints, and tooling. The context gap illustrates the distance between the limited available context provided to the AI and the actual, immense complexity of the real system it is trying to understand. This context gap exists for several reasons: the vast size of the data, fixed token limits on AI models, the dynamic and evolving nature of real-world systems, reliance on implicit knowledge, and inefficient retrieval limits. A major challenge is the sheer volume of code. We deal with millions of lines of code versus the very small, limited token count of the context window an LLM can process in one go. We also face the context reasoning trade-off. While short context allows for high-quality, nuanced reasoning, long context can degrade reasoning, potentially leading to oversights or coherence loss if the token limit is exceeded. The context reality gap highlights that context is always outdated. Due to continuous commits and changes, the context window provided to the AI rarely reflects the current, dynamic state of the codebase. Beneath the visible code lies a vast body of hidden knowledge, including critical trade-offs, conventions, and the original intent behind the code. This implicit knowledge is difficult for AI to grasp. Syntactic match does not equal semantic understanding. Simple keyword searches may retrieve content that matches the form, but misses the true meaning and deep context intended by the user. To manage the context gap, we must adopt an iterative cycle. Context is used to generate code, which is then tested, leading to feedback, which is used to improve the context. Better inputs improve outputs. By providing structured information like diagrams, detailed APIs, and specific tests, we give the LLM better inputs, resulting in context-aware, accurate, and high-quality outputs. We need advanced retrieval systems. Beyond simple lexical or semantic retrieval, we need architecture-aware retrieval that deeply understands system structure and component relationships to find the right context. Crucially, LLMs should query, not assume. Instead of assuming missing context and providing a flawed output, the LLM should proactively query the context retrieval system for missing information to provide an informed output. The iterative loop is a continuous cycle of improvement. It begins with generate, moves to test, identifies failure and fail, corrects errors and fix, and continues with repeat. AI native testing systems function as context reconstruction engines. They take formalized data and constraints as input and generate verified actions and results based on machine-readable contracts. These testing systems bridge the context gap. The large language model generates an unverified contextual flow, which the AI native testing system analyzes, validates, and transforms into a verified contextual flow for the target system. The goal is to run the right tests. The system should analyze a code change and intelligently select a subset of tests that are relevant and necessary for validation, rather than running everything. Failure analysis involves grouping errors by root cause. Failures can be categorized into database connection errors, API integration failures, or application logic errors, simplifying problem resolution. Tracing system impact is essential. By mapping dependencies, we can identify which components are impacted by a change, ensuring that relevant areas are tested and minimizing unintended side effects. We must use feedback as context. Test results and failure analysis are structured into actionable data and fed back into the LLM, continuously improving its knowledge base and future output. Testing acts as context reconstruction. By validating generated code against system contracts and gathering feedback, the testing system helps rebuild and refine the LLM's understanding of the system. Context is not static. It is always evolving. Consistent and rigorous testing is what keeps the context alive, ensuring that AI-generated code remains accurate and relevant over time. Thank you for watching this video on AI native testing systems and context reconstruction.